All right, so the meeting is being recorded. We start. Let me share my screen. Akosia, please, can you see my screen? Akosia, can you see my screen?
Yes, please.
All right. So today we're going to look at simultaneous equations. Others may say simultaneous equation. It is a noun. Okay. Now, it is part of your curriculum, the new curriculum, which means that it is very examinable. So it is not the simultaneous that we thought or we used to hear those days. I don't know. And share that in your ways. But this time around, this is examinable. And now they've added a graphical method. So we are going to consider all of these to help us. All right. So simultaneous equations. Their equation, I'll not do, how do you call it? Review, because I know we are far behind time. So let's go. Simultaneous equation, as you know, yes, are two or more equations with the same variables that are solved at the same time. Simultaneous equations are two or more equations with the same variables that are solved at the same time. So key thing to note is that there are two or more equations. One equation cannot be simultaneous. There should be two or more. And again, they should have the same variables. So if equation one has x and y, equation two should also have x and y. You cannot have t and p. No. And the number of variables, that one, it can be two, it can be three. But I think at your level, it's three. When you go to university, you are going to do 3 and 4 and co. So one thing is that the equations must be two or more. For an equation to be simultaneous, they should have the same variables. And also they are solved at the same time. Now, the goal is to find values of the variables that satisfy all the equations together. So the two equations that you have, find the values of those variables. And when you get those variables, when you put into any of the equations, it will satisfy it. So that is the goal of simultaneous equation. So now our problem now is to find all solutions common to the two equations or the coordinate of all points common to the two lines. So this is where the graphical method comes in. Now the equation given you is a line. The equation given you or the equation you have been seeing is a line. And those lines, when those two lines intersect, the point of the intersection is the solution to the equation. We'll get there when we start with the graphical method. Method of solving simultaneous equations. We have the try and error. But this one there, please don't try it. Oh. Examination, you don't have the whole day. Oh. Aha. Try. So you are going to put in the table. You have equation 1, x plus y is equal to 8. Then 2x minus y is equal to 7. Then you split them. X here, y is here. X plus y. Then x 2x minus y. We are looking for values of x, values of y. Then when you put into x plus y and 2 minus y, 2x minus y, you are going to have 8 and 7 respectively. So when you have x as 0 and y to be 8, when you have x as 1, y7, x2, y6, x3, y5, x4, y4, x5, y3. Now we are going to put this into the equations, whether it will satisfy the 8 and 7. When you put 0 and 8 into the equation, you get 8, which satisfies the first equation. Is it going to work for the second one? The second one is supposed to be what? 7. But here you're having -8. So it means that 0 and 8 doesn't satisfy the simultaneous equations. It's supposed to satisfy both equations, not only one. So it means that the answer is what? 5 and 3. X is 5, y is 3. And that will give us 8 for the equation 1 and give us 7 for equation 2. So what time is saying now, are you going to do this try and error to find the value of x and y? Anyway, this is an example or one way you can solve simultaneous equations. These are all simultaneous equations in two variables. That is x and y. This one to p and q, two variables. Now let's start with the graphical method before we come to elimination and substitution. I think that one is familiar to all of us. So let's start with the graphical method first. Yes, so graphical method. Graphical method. Now, with the graphical method, when you are given the equation, convert the equation to slope-intercept form. Slope-intercept form. And what is the slope-intercept form? It is in the form y is equal to mx plus c. This is what we call slope-intercept form. Now, we are going to consider the m and also the c. Now, this is a line. This is a line. Take note. The m is the slope of the line, what we call the gradient. Then the c is y-intercept. Y-intercept. So y-intercept is the point on the y-axis. Assuming you have your graph like this. This is your x-axis, this is your y-axis. The point on the y-axis where the line touches that is the y-intercept. The point on the y-axis where the line touches is your y-intercept. So assuming this is the line, you could see that the line touches the y-axis here. So assuming here is 2, it means that the y-intercept is 2. Should the line touch the y-axis here, the point here becomes your y-intercept. Let's say -3. So your y-intercept is what? -3 in this case. Now, the slope determines how steep the line will be. The slope, the m, determines how steep the line will be. If the m is positive, the line points upwards like this. The line points upwards. Now, if the slope is negative, If the slope is negative, the line points downwards. If there is no slope, if there is no slope, if there is no slope, the line is horizontal. There is no slope. In that case, m is 0. So this is a way for you to predict how the line will look like on the graph. Understanding the varieties of the slope, that if you have the m to be positive number, the slope is pointing upwards. If the m is negative, the slope is pointing downwards. If the m is 0, there's no slope. The line will be what? Horizontal. So now let's take some examples. And also another thing, yes, before we take an example, we know that the slope, the gradient, is change in y over change in x. This is what you know in GHS. Good. So if you have slope, let's say your slope m is equal to 2 over 3. You know it is change in y over change in x. So it means that the 2 is the change in y and the 3 is change in x. So this is what you are going to do. You are going to move 2 steps upwards from the y-intercept. Take note. From the y-intercept, you are going to move 2 steps upwards along the y-axis. And because the 3 is on the x, changing x, you are going to move 3 steps to the right. Listen again. Your starting point is the y-intercept, the c, the value there. Stand over there and move 2 steps upwards because the 2 there is positive. You are moving 2 steps upwards or along the y-axis. Then you move 3 steps to the right. 3 steps to the right on the x-axis. If the slope was, say, negative 3 over 4, you are going to move, always know that it's changing y over changing x. So the top is the y, the down is the x. You're going to move 3 steps downwards along the y-axis because it's negative. Then 4 steps to the right, always to the right, always to the right on the x-axis. So 3 steps downwards from the y-intercept and 4 steps to the right. Yes, your hand is up. Let's hear you.
Please, so when the x is even negative, you still go to the right.
When the
X.
x is what?
I said x, you always go to the right. So when the x is
Yes,
negative, you still go to the right.
thank you. So now this is a fraction. If you have, let's say, negative, okay, let me put it this way. If you have, let's say, 1 over negative 2, you know this is a fraction, it is not vector. If this was a vector, the negative is affecting only the 2. The 1 is free. But because it is a fraction behave like Siamese twins. For Siamese twins, you cannot tell me you are going to La Paz and the other one is going to circle. You lie. We are all going to La Paz. We are all going to circle. But for vector, one can go to La Paz, one can go to circle because they are different entities. So in this case, the negative is affecting everything. So you write as 1 over 2, negative 1 over 2. So putting the negative down is an improper way of writing a fraction. Always you bring it to the top. So in this case, even though you can see 1 over negative 2, but it is improper. So change it to negative 1 over 2. And in that case, you are moving 1 downwards, 2 to the right. If you have the m to be negative 1 over negative 2. In this case, the negatives will cancel, where we have 1 over 2. So you are moving 1 up, then 2 to the right. My dear, are you fine? Hello?
No.
Okay. I am saying that this is a fraction. If you have 1 over negative 2, the negative is affecting the entire body. This is one entity. 1 over 2 is one body. So the same as negative 1 over 2. If it was a vector, the 1 is free, the 2 only is negated. But this is a fraction. So the negative there affect the entire value. It is negative 1 over 2. It is not 1 over negative 2 as you are seeing there. So this is improper way of writing a fraction. So the correct way is that bring the negative up to be negative 1 over 2. And always moving to the right. 2 to the right, 1 downwards on the y-axis. Now, if you have negative 1 over negative 2, negative 1 over negative 2, the negatives will cancel. Now, what do we have? We have 1 over 2. So in this case, the 1 is positive, the 2 is positive. It's a positive integer now. So 1 moving up, 2 to the right. Hello?
Say.
What do you want to hear?
Yes, I get it now.
You get
So
it
it
now.
means that yes, no matter like everything you do, so the x will be to your like you move the x
To
to the
the
right.
right, thank you. Always
Thank
right, F
you.
to the right. That is the original direction. Unless you are going opposite. Unless you are going opposite, listen carefully. Always the direction of the x is to the right. But the y, it depends on the integer. If it is negative, you are moving downwards. If it is positive, you are moving upwards. So now look here. If you have m to be negative 1 over 2, originally the movement will be 1 down, 2 right. This is the original movement. But in opposite wise, it will be 1 up, 2 left. This is opposite movement. Take note. The original movement here, according to the gradient you have, is 1 down, 2 to the right. So if you want to go opposite direction, that will give you what? 1 up, then 2 to the left. Please, are you clear with that?
Yes, please.
All right. Now let's take an example. Now let's try these equations.
Form 1 for is a crop introduction to crop.
That's it. Yeah, crop is yeah, detail.
Ube edu
Okay. So now you are solving for this equation. X plus y is equal to 5. X minus y is equal to 1. X plus y is equal to 5. X minus 1 is equal to 1. Is that the case? Yes, x minus y is equal to 1. So equation 1, equation 2. We are solving this graphically. We are going to change the equations to slope-intercept form. And you know slope-intercept form is in the form y is equal to mx plus c. So equation 1, we are making y the subject, and that will be y is equal to the x will there become negative x plus 5. For equation 2, if you want to make y the subject, somebody will do this way. Negative y will stand alone here. Then x will go to become negative x, then plus 1. You want the y to be positive. So what do? You divide all the 10 by what? Negative 1. So it is y over negative 1 is equal to negative x over negative 1. Then 1 over negative 1. Negative will cancel negative. We have y here is equal to negative will cancel negative. We have x. Then 1 over negative 1. Don't forget that the negative affects everything. So that will give you what? Negative 1. So that will become the slope intercept for equation 2. Y equal to x minus 1. This is the slope intercept for the two lines. Now we want to draw these lines. What do we need? We need the m's, the gradient. We need the m and the c. So equation 1. What is the gradient for equation 1? Let me call somebody. What is the gradient for equation 1? Equation 1 gradient. Benedicta Owusu. What is the gradient for equation 1? Benedicta Owusu. Yes. Okay. Isa Ibrahim, let's hear you.
Sir, please, negative 1.
Negative 1. Okay, negative 1. What about the C? Yeah, what about the C? Yeah, Jude, watch it. C.
Sir, please, 5.
The C is 5. Thank you. So let me write here equation 1. These are information for equation 1. Now equation 2. Equation 2, what is the M? What is the C? Yes, let me call I'm far away. McDaniels, yes, McDaniels, let's hear you. M is positive 1. What about the C? Negative 1. Thank you. Don't forget that you are going to use the M and the C to draw the line. So equation 1, our M is the same as what? Negative 1 over 1. I hope you agree. Because we know that the slope or the gradient is in the form change in y over change in x. So if you are having negative 1, it's the same as negative 1 all over 1. We know that every whole number is over 1. So fractionally, negative 1 is negative 1 over 1. The same way, the M for equation 2 is 1 over 1. So now let's
Hello,
go
sir.
to equation 1. Let's go to equation 1. Are you Samuel? Are you? Hello, are you? Hello, are you? Okay, Nanayao. Hello, Nanayao.
Hello, sir.
Good.
Sir,
Now,
sir,
yeah, our
sir,
M is
please,
negative. Yeah. Yes.
sir, please, I don't understand. Can you please go over?
Please, have you been here since we started, or you just came?
I just came.
Aha. Oh, Ghanaian children. Now you see now by now, Kase will say you see my.
Oh, okay.
Aha. Anyway, you follow along. Okay, follow. Yes. We'll come back, but then you don't. Let's move. Christabel Ankuma. Christabel Ankuma.
Sir,
Good. Now equation 1. Our M is negative
sir,
1 over 1. Yes, please. Can you hear me?
yes,
Good. I'm saying that for equation 1, our M, the gradient is negative 1 over 1. So what will be the steps?
sir, please forward.
We have negative 1 over 1. When we were doing the introduction, don't forget, we said that the numerator is movement along the y-axis and denominator is movement along the x-axis, always to the right. But the numerator is either you're moving up or down, depending on the integer. We said that. Yes, Godwin.
Sir, please, that time I wasn't in.
Okay, Godwin. Okay, Papa Gode. All right. Okay. Divine, Gerson. Divine, Gerson. Benedicta Owusu. So these people brought the body here and took the soul and spirit away. Chai. All right. Blessing Ejewa. The body they your spirit Spanish. All right, Agosia, you are here. As for you there, your spirit, everything is here.
So you see when we're starting, we're like the constant, sorry, the C is Y intercept.
Good. Where the
So
line touches
that
the
means,
y-axis.
yes. So that means that's where,
Okay, so
so
now
you
the
stand at
question is, you stand at the what? 5. Good.
the 5 years on the Y
Good.
axis.
On the y-axis.
Then for the equation 1, you move to the down
How many
just
steps?
once because it's -1 once.
-1. So you are moving 1 step down. Good.
Yes. Then for the X axis, that one you always move to the right, so you move 1 on the right,
Thank
to the
you.
like to the right side on the X axis.
All right. Thank you, Akosia. All right. So let us locate our y-intercept. Our y-intercept is 5. Where the line touches the y-axis. So 5 is here. And we are going to use the M to do the movement. M is -1 over 1. So -1 means move 1 step down, then you move 1 step to the right. So from here, we move 1 step down here to the 4, then right 1. So this will be the bar stop. Are you watching? What?
Yes.
Yes.
Okay.
Yes, sir.
So from the 5, that is the starting point. The y-intercept. You are going to move one step down because it's -1. So one step down, then
Yes,
one
sir.
step to the right. Now you are moving again. You can go as many as you want. That one depends on you. I can just go one and I say my break. You can decide to go like 5 times. Yours is to get some point where you can draw the line. 2 points, 3 points is fine. But as many you want to go, you are allowed to go. Then from the B becomes my new starting point. Assuming I go to Akos's house to eat jollof, then I remember that Bennett too can cook fried rice, so let me go to Bennett's house. Am I moving from my house to Bennett's house or moving from Akos's house? Good. From
Akosia's
Akos's
house.
house because now I am in
Akosia's
Akos's
house.
house. So if I'm moving, I am going to move from my house. So now I was A.
So I
Good,
don't
thank
understand.
you. You follow, you understand. Follow. I was standing at A initially. That is a 5. And I moved to B. So if I want to move again, I am moving from B. That's my current position. So I'm moving one step down, one step to the right. So one step down from B will come here. Then to the right will go here. This is my new position. If I want to move again, I am moving from my current, that is C. Move one down, move one right. So this become what? The movement. So let us draw the line. Let us draw the line.
Sir, I have a question.
Yo, go.
Say, I said that when we started with the A, when we
Okay.
started, you started with -1 and +1, right?
Yes, please.
So say as follows. So the B2 is -1, +4, or
No, it is we are using the M to do the counting, the movement, the steps. The step is always -1 and 1 according to the M we have. So you are moving one step downwards, one step right, one step downwards, one step right, like that. So looking at where you are, your current position, you move one step downwards, you move one step right because of the gradient we have there.
okay.
X plus 5. What is the equation? X plus y is equal to 5. Okay. So that's equation 1. You can see that the line is there. Equation 2, we have 1 and what? 1. So one step, good. Because the 1 is positive, it means you are moving one step up, then one step to the right. Always the denominator is what? Right. No, there's no negative, please. Look at it. It's 1 and 1. 1/1. Hello.
Hi.
Good. The M is the coefficient of the. So 1 is here. 1.
Hi.
And 1 is the same as 1/1. So meaning you are moving one step up, then one step to the right. What is the y-intercept?
-1.
What is the y good? -1 is the y-intercept. So let's go to the graph.
-1.
Let's go to graph. -1. So -1 on the y-axis is here.
Y-intercept is -1.
Thank you. We have done that. So we are going to stand on the y-intercept to make our first move. Our first move. So 1/1 means one step to the right, one step up. So from here we move one up, one to the right here. Now we are at F. From F, we are moving one step up, one step to the right, like this. From G, we are moving one step up, one step to the right. So it will also be at D here.
Another intercept.
Have you seen that?
Yes, sir.
Somebody may say that, okay, sir, the line is the points are going this way. What if you want the point to come this way too? What do we do? So that brings what we call the opposite direction. Opposite. So originally we are going this way, but if you want to come here, that is opposite. And in that case, I demonstrated here that for opposite direction, if the gradient is -1/2, where we know that originally it is one step downwards, two steps to the right. Opposite to be what? One step up, two steps to the left. Do you get it?
Yes, sir.
So now our gradient here is 1/1. Originally it is one step up, one step to the right. But if you want to go opposite, it will be one step down, one step to the left, isn't it? So now go back to your original home, that is the y-intercept, and start the movement from there. So you are standing on E. We are moving one down, one left. We have H. Move one down, one left. We have I. We move one down, one left. As many as you want to go. So you can see that the line, it is following. Now let us draw our line. The equation is x minus y equal to 1. Was that the equation?
X minus y equals to 1, yes.
X minus y equal to
1.
Equal to 1. Okay. So that is our line over there. Let me change the colors. One pink. This one should be blue. Okay, blue. So one for the girls, one for the boys. Blue for boys, pink for girls. Pink, baby pink, because of my girls are babies. All right. So now these are the two lines that we have. Sorry. So what is the value for x and y in the equation? Where the two lines intersect, that is your answer. Where the two lines intersect, that is your answer. So this is the intersection point. Trace it toward the x-axis and the y-axis respectively. So to the x, it is pointing at 3, and to the y, it is pointing at 2. So it means that the value for x is what? 3, and the value for y is 2. So that is the answer. That is the answer. Okay, so that is key. 3 and 2. Now let us put 3 and 2 into the equations and see if it will satisfy it. We have x plus y is equal to 5. Then x minus y is equal to 1. And we are saying that x is 3, y is 2. Left hand me here. Here is 3 and 2. Are we getting 5?
Yes.
Yes, sir.
Okay. Now let's see. X is 3 minus y. Y is 2. Are we getting 1?
Yes.
Yes, sir.
Thank you. So 3 and 2 are the solutions for the two equations because it satisfies both equations. So this is how you solve simultaneous equations using the graphical method. Now let me give you another approach.
Okay.
Please mute yourselves. Another approach of using the graphical method. You will form coordinates. So create x and y. So give yourself some values for x starting from 0 or negative. You can start from negative something out to. So have 0, 1, 2, and 3. Now go and put this into the equations. We have y is equal to, is it x minus 5 or plus 5? Yeah, someone's hand is up. Let's hear you. Pardon, equation 1. Is it y equals negative x plus 5?
Yes, please.
Okay. Okay. Good. Now we are forming our own coordinates. Assume any positive value for x. We are going to put that into the equation to find the value for y. So when x is 0, y is what?
5.
Good. Y is 5. So when you put x into 0, it will be y is equal to 5. When x is 1, y is what?
4.
4. Good. 4. So y will be 4. When x is 2, y is what?
3.
3. When x is 3, y is
2.
2. Good.
Yes, y is equal to negative x plus 5.
Now you go to the negative x plus 5. Hey. Now let's get the second equation.
X minus 1.
X minus 1. Good.
Yes.
Okay. So in this case, y do what?
Minus 1.
Negative 1. Negative 1.
Negative 1. When x is 1, y will be
0.
0.
yellow. When x is 2, y will be
1.
wine. Good. When x is 3, y will be
2.
So you can form as many as you want to. We are only maintaining this. We are going to plot this. So write them. I'll ask you to give to me. We are going to plot them. Let's plot the first line. So 0 and 5. Okay, please give me the point for equation 1.
0.
My people.
0, 5.
0, 5.
1, 4.
Okay, one person. I'm going to have 1,
4.
1, what? 1, 4,
3.
1,
2, 3.
2,
3.
3, 2, 3, then last one.
3, 2.
3, 2.
3 what?
2.
2.
3 what?
2.
2.
3 2. Okay. Don't forget you can do as many as you want. Now that you have your point, you can just draw a straight line. No. Mute your microphone. Why? I'll manage to mute all of you, but not keep the green side. Please mute yourself, please. I've done that, but I don't know why it is still working here. Okay, good. Sasa. All right, so now we have our points. Just draw your straight line to pass through. Good. So if you could see that we didn't have point for this side, just start from negative. We started with 0, 0, 1, 2, 3. You can also start from -3, -2, -1, 0, like that, and you get some values to at the other side. But it doesn't matter. Then equation 2, the coordinates you have 0 and -1. 0 and -1. 0 and -1. Then we have what again? I told you mute yourself. You didn't mute. Okay. Yes, Delvin, Ado, Delvin, let's hear you. Hi, Delvin. Your hand is up. What's the issue? McDaniel, your hand is up. What's the issue?
Oh, so this method they are teaching us, can it be used in examinations?
Yeah, so straight. Examination, straight. Are you okay? Can we continue?
Yes, sir.
All right. Maoli.
Sir, please,
Yes,
I want
sir.
to ask a question.
Okay.
Please, which topic are we teaching right now?
We are doing solving simultaneous equation using graphical method.
Okay. Thank you.
You are welcome.
So please, I thought you said this one is forming coordinates, or it's under the graphical method.
It is under the graphical method. That is another way of doing the graphical method, please. So instead of using the gradient to do the movement up and down, you can form your coordinate and you plot. So you have looked at two things. Good. Under the same graphical method, we have looked at two scenarios or two instances. One, you are using the gradient to do the movement along the x and y axis without wasting time to plot points. Secondly, you can also get your own coordinates, you plot them, then you draw the line. And that's what you are doing now. Are we fine?
Yes. Yes.
So the equation, we have 0 and -1 as one coordinate. We have 1 and 0 as another coordinate. So let's see 1 and 0. 1 and 0. We have plotted. We have 2 and what? 2 and 1. then 3 and 2, 2 and 1, 3 and 2, 2 and 1, 3 and 2. So 2 and 1, 3
And
and
3
2.
and 2.
Okay, good. So you can see that the lines are, the points are going this direction. If you want to get some here, then make sure that when you are forming your coordinates, you include negative value for x so that you get the y counterpart. We started from 0, 1, 2, 3. That's why you are not getting some point at the negative side. So if you want to get it, you start with negative values. So now let us plot. Let us plot our graph. Sorry, our line. Let us draw our line. Y is equal to x minus 1. So you see the same as the first one we did. And their intersection will be the value, the solution for the equation. So x is 3, y is 2. Are we good?
Yes.
Yeah, so these are two ways. Yes. These are two ways you can use graphical method to find the solution of two simultaneous equations. It's either you are using the gradient approach, where you convert the equation to slope-intercept form like this. Slope-intercept form, y is equal to ms plus c. Get your m. The m will tell you the movement. The numerator will tell you move up or down along the y-axis. Then the denominator is always to the right on the x-axis. And the c is the y-intercept, where the line touches the y-axis. So stand on your c, use the m to do the movement. Or come and get your own points, your coordinates. Get your own coordinates. Get your own coordinates. You plot them. You draw your line. Yes, GSM. What's the issue? GSM, is it KD? Your hand is up.
Please, can you slow down for us? It's like you are getting too fast.
It's almost time.
All right. Yes, our time is up. So, well, if you follow, let me do a quick recap.
Okay.
If you followed what we did, we are talking about simultaneous equations, and we have so many ways of solving. We have elimination method using graphical. But then, because the eliminations are familiar to us, we want to start with the graphical method. How we can use the graph to find the solution of simultaneous equations. So we were given equation x and y is equal to 5, x minus y is equal to 1. Excuse me, let me mute some people. Please listen. Good. Now we have these two equations. X plus y is equal to 5, x minus y is equal to 1. We want to find the value for x using graphical method. And for graphical method, these are lines. So go and draw lines. And where they intersect, that will be the answer, the solution. So how do we draw the lines? And I gave you two instances. Convert the equation to slope-intercept form. And slope-intercept, we have y is equal to mx plus c. That is the form. So change equation 1 to look like m is equal to y is equal to mx plus c. That is make y the subject. And when we did that, we have y is equal to negative x plus 5. So the m here is the coefficient of x. That is negative 1. Then equation 2, we made the y the subject. We had y is equal to x minus 1. Here, the m is what? The coefficient of x. That is positive 1. And I said that you are going to use the m to do movement on the graph. The constant c is the y-intercept, where the line touches the y-axis. So when we look at this graph that we have here, the pink line is touching the y-axis at 5. So that is the c. The blue line is touching the y-axis at negative 1, and that is the c. So go and plot your c on the graph. In this case, our 5 is the equation 1, the c is 5. So go to the graph and plot your c, 5. Now use the m with the gradient to do movements along the x and y axis. We know gradient to be changing y over changing x. So the top is for y, the down value for x. In this case, we are having negative 1 over 1. So the negative 1 is for y, then 1 is for the x. So you are moving negative 1 on the y-axis. Negative 1 means move 1 step downwards because of negative. If it was positive 1, you are moving 1 step upwards. Good. So 1 step down, 1 step to the right, 1 step down, 1 step to the right. So watch here. From the 5, if you should move 1 step downwards, it will come to the 4. Then you move 1 step to the right. So that's where the B is. Now, standing on the B, you want to move again. You move 1 step downwards, then 1 step to the right. So you come and end up here. Standing on the C, you are moving 1 step downwards, 1 step to the right, like that. Now you have your point. You draw your line. Now, for the equation 2, the m was what? 1 over 1. So meaning 1 step upwards, 1 step to the right. Good. Our intercept, y-intercept is negative 1, where the line touches the y-axis. So negative 1, plot to negative 1. Then you move 1 step up, 1 step to the right. So from the negative 1, 1 step you move here. Then to the right, you come here. So this F. You are standing on the F now. You are moving 1 up, 1 right. That is the G. You are standing on the G, move 1 up, 1 to the right, like that. So you have your point. You draw your line. How did we get H, I, and J? That is the opposite direction of E, F, and G. So you know that the gradient is 1 over 1. That is 1 up, 1 to the right. If you want to go the opposite direction, it will be 1 down, 1 to the left. So you stand on the E, which is the original start point, the intercept. Then you move 1 down, 1 left. You have H. Stand on the H, move 1 down, 1 left. Stand on I, 1 down, 1 left, like that. You have the J. So that is the opposite direction. Now you have all these points. You draw your line. So where these two lines intersect, where they meet, that is the value, the answer. So trace it to the X. Here, it is pointing on the 3. Here, it is pointing on the 2 on the y-axis. So the answers are 3 for X, then 2 for Y. That is one way of using the graphical method. Another way of using graphical method is create your own coordinates. Create a table for yourself. Like what you have done. Get your own X values. You can start from negative something, 0 up to any, but we only did 0, 1, 2, 3. It is not compulsory. Create your own. Okay. Now, you want to find the values of Y. So put the values of X into the equation 1 by 1 and get the respective Y values. So when x is 0, when you put x of 0 into the equation, y becomes what? 5, and we had 5. When you put x is 1 into the equation, we have y to be 4. When you put x 2 into the equation, y is 3. When you put 3 into the equation, y is 2. So now this is what we have: coordinates, pair. Now you do the same thing for equation 2, using the same x values. So when x is 0, when you put into the equation 2, y will be what? -1. When x is 1, y will be 0. When x is 2, y will be 1. When x is 3, when you put it inside, y will be what? 2. Now you have these coordinates and also these coordinates. You just go to your graph, you plot them. We plotted them and we had this point. You draw your lines where they meet. That's the answer. So 3 for x, 2 for y. When you are getting the coordinate, please, I repeat, it is your own preference. Oh, you can start from negative something up to 0, up to like that. Yeah, so that one, you're not restricted. Please, are we fine? Are we fine?
Yes.
Yes, sir.
Yes,
Good.
sir.
So we are going to do this one. I'm giving you an assignment. Go and try it using the graphical method. The B.
Sharp.
The B and the C. Anna. The B and D. My sister Margin. Go and do B and D, okay?
Okay.
Okay, sir.
So let me give you the yes, please.
Sir, please, the head word. No.
The what?
The mark word.
Attendance word.
Attendance.
Yes.
So please, should we plot it
You
on the graph? Like, should we do it in the graph?
yeah, do it in the graph. Yes, graph, please. Graph.
Okay, sir.
Okay.
Graph.
Hey, is it gone?
Attendance word is enable.
Hey,
Enable. The same thing.
Enable.
Mm. Some people will say enable, others will say enable. Yeah, the same word.
Enable.
Yes. So
enable.
ENABLE. ENABLE.
It's
Enable.
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 That's bad.
Okay.
Enable.
No.
Enable.
Says
Sir,
enable.
capital letter first. Sir, enable.
Okay. Enable you.
Say no.
Sir,
All right. So
enable.
thank you so much for your
Enable.